similar polygons. So polygons that are the same shape but not necessarily the same size. So we did a whole activity before we went on break about two things that can be similar but not necessarily the same size. So same shape, different size. Symbols. So we remember the congruent symbol is your equal sign with the squiggle above it. Okay, congruent meant equal in size and similar in shape. So if we take the size away, equal size, we're just left with the squiggle. So similar is just the squiggle. And once again, like I just said, the equal sign represents the same size, and the squiggle represents the same shape. All right, two polygons are similar if and only if. So remember that IFF is not a typo. It means if and only if. Both of these statements are true. So their corresponding angles are congruent. And the measure of their corresponding sides are proportional. So looking at these two polygons, all of their angles that correspond to each other have to be congruent. So whenever we talk, let's say angle A, which is its corresponding angle? Which one would be the same? Thank you. Good. So it's the same in a different figure. So E would have to be congruent to A. All right, and then B, which one corresponds to B? F. So those two would have to be congruent. Remember, each arc shows the congruency there. So C would have to be congruent to G. And then D would have to be congruent to H. All right, so not only do all their angles have to be congruent, their sides have to be proportional. So do we remember what a proportion, how we write that from a couple weeks ago? We did ratios and proportions before we went on break. You don't remember? What would be a proportion if I asked you? Like just any kind of proportion.
Like a part of something.
Like a part of something. So, like what? Like half. So half or 3/4 or something along those lines. What is that? A proportion. How do we write it? As a what? Okay, those are ratios as the colon.
Oh, the
How else could we write it?
no, I don't know.
1/2, 3/4 fraction. Thank you. Okay, so whenever we say their corresponding sides have to be proportional, that means every single side has to be the same fraction. Okay, so if I said AB, what's its corresponding side? EF. So you would have to write them as a fraction. Okay, and then that fraction has to be equal to, if I said BC, what's its corresponding side?
FG.
FG. And then if I said DC, what's its corresponding side? HG. And then last side, AD. EH. So the corresponding sides get put into fractions, and then each fraction has to be equal to each other. That's what it means to be proportional. Got it? Okay. All right, next. The similarity ratio is the ratio of the lengths of the sides. So we just wrote it, I don't really have to have it twice. So we we already wrote it. That's what we're talking about, okay? So those are our similarity ratios. All right, first question. If we say polygon ABCD is similar to polygon EFGH, then if I rewrite it CBAD, how would I have to rewrite the second polygon? G F E H. Very good. So those are going to match up. All right, number 2. If triangle IJK is similar to triangle LMN, then we can complete each statement. So angle L is congruent to which angle? I. Very good. It matches up. And then IJ is the same as LM in the other triangle. So then what side is the same as NM? KJ. Good. Make sure you write it in the same order. So N matches up with K, M matches up with J. Order matters. Any questions there? All right. Next, determine if the polygons are actually similar. If so, write a similarity statement and give the similarity ratio. So we had 2 things we had to check up on the top there. What was the first thing we needed to know if 2 polygons were going to be similar? Kobe?
Same shape but not same size.
No. Yes, Jonathan? Good. So the first one is congruent what? Angles. Good. So we need congruent corresponding angles. So let's look. Does the 90 match the other 90? Does the 30 match the other 30? Does the 60 match the other 60? So do we have congruent corresponding angles? Okay, so step 1, check. What's the second thing we need to check?
The measure of the corresponding side.
Yeah, we need sides to be proportional. So that means if I go 6, we have to make those fractions. So 6 corresponds to what side on the other triangle? 3. So that fraction has to equal, if I go 8, what's its corresponding side? 4. And that fraction has to equal, if I go 10, it's to 5. So if I reduce each of those fractions, what do each of them give me? 2. So are all of these the same?
Yes.
2 equals 2 equals 2. Check.
So they are similar.
So they're similar, right? We've got corresponding angles congruent and sides proportional. Yes? Okay, so if they're similar, it says to do 2 things. Write a similarity statement. So what that means is, I need letters on here. Name this A, B, C, and name this one D, E, F. Okay. So similarity statement is going to say triangle A, B, C is similar to triangle D, E, F. So that's our similarity statement. You say this triangle is similar to this triangle. So it says write a similarity statement and give the similarity ratio. Okay, so our similarity ratio we already found. Similarity ratio is going to equal 2 to 1. So this triangle is double this triangle. So it's a 2 to 1 ratio. Does that make sense?
How'd you get the 1?
Because all of these technically reduce to 2 over 1. So it's a 2 to 1.
So the bottom one's the right and the top one's
Mm-hmm. All right, any other questions on that? Okay. All right, next page. Proving triangles similar. Okay, so, yes. Yes. We have 3 shortcuts for triangle similarity. So we can tell that triangles are similar without doing all 3 congruent angles and all 3 sides proportional. Okay, we've got shortcuts. All right, so I'm going to teach you the 3 shortcuts you can use. So first shortcut is called angle-angle similarity postulate. So AA similarity. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar to each other. Okay, so yep, that's a shortcut. So instead of proving all 3 angles, you can just do 2 and 2, and you know. Any questions there? Okay, the next shortcut, side angle side similarity. A lot of people call that SAS. All right. So if an angle of one triangle is congruent to an angle of a second triangle, and the sides that include those angles are proportional, then the triangles are similar. So right now I've got A and D congruent. Okay, so I need the 2 sides that connect those 2 angles to be proportional. So what is one side around angle A? Would be one side of this triangle. AB. So if I said AD, what would be its corresponding side in the other triangle? DE. Okay. So those 2 sides need to be proportional to what other 2 sides? AC. Good. And DF. So that way we have the 2 sides that make the angle proportional. Does that make sense? Okay, so that would be side, angle, side. Any questions there? Does that make sense? Okay. All right, last one is side, side, side similarity. So instead of looking at any angles, if you just prove all 3 sides are proportional, then you have similarity. So we would say AB is the same as which side? DE. And it needs to be proportional to, pick another side. AC and DF. And what's your third side?
BC over EF.
BC, EF. Very good. So then we could say those are similar by side, 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 because we proved all 3 sides were the same. Any questions about your 3 shortcuts?
No.
All right, we're going to practice them. So flip the page. All right, question says, determine if the triangles are similar. If they are, let's underline because it's telling us what to do. So if the triangles are similar, we need to write a similarity statement, name the postulate or theorem, and if they are not similar, we just need to write not similar. Okay, and then the most important piece is show your work. Any questions there?
No.
Okay, so looking at number 4, what information do we have on there? Like what kind of stuff do we have? Do we have angles? Do we have sides? What do we have?
We got like the 8, 2, 3, 12 and stuff.
Okay, so we've got we don't have any angle measurements, but we have sides, right? Okay, so if we start with the sides, if I do 3, what's its corresponding side? 12. And if I do 2, what's its corresponding side? 8. Okay, so what do those, what's 3 over 12 reduced to? 1/4. What's 2 over 8 reduced to? 1/4. So do they have the same similarity ratio?
Yes.
Okay, so the SR, the similarity ratio, is 1/4. They're the same. Do I have a third side?
No.
No. So can I do side, side, side?
No.
No. Okay. Do I have angle measurements in there?
No.
No. So can I do angle, angle?
No.
No. So what was my only other option? No.
Side, side. That was the first one.
No. We already said we don't have the angles to do angle, angle.
Side, angle, side?
Side, angle, side. So I've got two sides. Where's my angle? Right here.
Oh. Between the two sides.
In between the two sides. So right here and right here. What do I know about those angles?
Oh, 180.
No?
90.
Stop guessing.
Ooh.
We just did a review. They're congruent, I agree, but why? What was their relationship name? Because we just did a review over what relationship those are. Vertical angles, very good. Okay, so those angles are vertical angles. Okay. So angle ACB is congruent to ECD by vertical angles. All right, did I prove that they are similar now?
Yes.
Did I prove AA, SAS, or SSS?
Yes.
Yes. So, since I know I've got all the work that proves that they're similar, I need to write that. So angle AVC is similar to triangle BDC. And then which one of the three shortcuts did I use? Side, angle, side.
Why do you change the... You said ECD in the first one.
Huh?
What am
Oh, I switched the letters around. No, you can keep it the exact same as the angles. Okay. So we got that one, side, angle, side. Let's look at number 5. What kind of stuff do we have on number 5?
Measurements?
Measurements of what?
Angles.
Angles. So, do you think we are going to use side, side, side?
No.
No. Do you think we're going to use side, angle, side?
No.
Could. How many sides do you need for side, angle, side? 2. Do you have 2 sides on either of those triangles?
Yes. No.
You only have 1 side on each of these triangles, right? Do you have either of the other sides on those triangles?
Oh, no.
So how many sides do we have on each triangle?
One.
1. So is that going to help us do side, angle, side, or side, side, side? No. So what's our only option we should be trying to do?
2 angles.
Angles. 2 angles. Okay. Does the 30 match? Yeah. How am I moving ABC to DEF?
Rotate.
Rotating, right? A reflection would be right here. This is going to rotate over. So 30, 60, how much does this one have to be? 90. Why does it have to be 90? Good. A triangle has to add up to 180 degrees. So if this is 30, that's 60, that adds up to 90, so this one has to be 90, correct? Okay, if that's 90 and that's 30, we're at 120. So how much does this third angle?
60.
60. So do all the angles match up?
Yes.
Yes. Okay, so do we have triangles that are similar?
Yes.
Yes. So we need to write what?
Similar thing, like
A similarity statement. So triangle, what? Name it.
ABC.
ABC. Similar, put the squiggle. Name ABC the same in the other. What is it?
DEF.
DEF. And then by, which shortcut do we use?
By angle, or 2 angle, or...
Good. Angle, angle, similarity. We did by AA. All right, do you have any questions? Okay, we're gonna pause there today, and then we'll do the word problems and stuff tomorrow.